Most bridges connect two pieces of land. This one had to cross an open sea. For centuries, the Great Belt separated eastern and western Denmark. Ferries carried millions of passengers across these waters every year, but the crossing was never guaranteed. Strong winds, rough seas, and winter storms could bring everything to a halt. Building a permanent bridge seemed impossible. The water was deep, the weather was unpredictable, and beneath the surface lay one of Europe's busiest shipping lanes. So how do you build a bridge across an open sea without interrupting the ships that keep an entire region moving? The answer would become one of Denmark's greatest engineering achievements. For decades, ferries served as the country's vital connection. They linked families, businesses, and industries from one side of the nation to the other. But as traffic increased, waiting for the next ferry became a costly delay. Denmark needed something permanent, something faster. But solving that problem meant overcoming the sea itself. The Great Belt is far from calm. Powerful currents sweep through the strait every day, while the seabed changes dramatically from one location to another. Any structure would have to withstand constant waves, violent storms, and freezing winters for generations. Then engineers faced an even bigger challenge. The bridge couldn't block international shipping. Some of the largest cargo ships in Europe pass through these waters every day. They needed a navigation channel wide enough and high enough to allow safe passage beneath the bridge. That single requirement changed everything. Instead of one continuous bridge, engineers designed an entire crossing system. The western section would use a series of lower concrete spans. The eastern crossing, however, demanded something far more ambitious. A massive suspension bridge. Its main span would stretch more than 1.6 kilometers between two towers, making it one of the longest suspension bridges in the world when it opened. Those towers would rise more than 250 meters above the sea. But before anything could reach the sky, the real work had to begin below the water. Construction started with enormous foundations anchored deep into the seabed. Specialized vessels carefully positioned giant concrete caissons, while underwater crews worked in difficult conditions with limited visibility and powerful currents. Precision was everything. A small error at the foundation could become a massive problem, hundreds of meters above the water. Once the foundations were complete, the towers slowly began to rise. Section by section, reinforced concrete climbed higher into the wind. As the structures grew taller, construction became increasingly difficult. Heavy cranes had to lift enormous components, while engineers constantly monitored movement caused by wind and changing weather. Sometimes storms forced the entire operation to stop. The sea always had the final say. But once conditions improved, work continued. Then came the most critical stage of the project, the suspension cables. Rather than installing one enormous cable, engineers pulled thousands of individual steel wires across the towers, again and again, until those tiny strands formed two incredibly strong cables capable of supporting the entire bridge deck. It was a slow process that demanded remarkable accuracy. There was no shortcut, only patience. With the cables complete, construction entered its most dramatic phase. Massive steel deck sections arrived by sea aboard giant barges. Each piece weighed hundreds of tons. Floating cranes lifted them high above the water, while crews carefully guided every section into its exact position. Sometimes the difference between success and failure measured only a few centimeters. Yet one by one, the sections locked perfectly into place. After years of planning, engineering, and construction, the two ends of the bridge finally met. The final gap disappeared. For the first time in history, travelers could drive directly across the Great Belt without relying on a ferry. The impact was immediate. Travel times fell dramatically. Freight moved faster across Denmark, and into Scandinavia. Communities became more connected. Businesses became more efficient. The bridge didn't simply cross the sea, it reshaped the country. Today, millions of vehicles travel across the Great Belt Bridge every year, often without realizing the extraordinary engineering hidden beneath the roadway. Deep below the waves, massive foundations continue resisting the relentless force of the sea. High above, towering cables silently carry thousands of tons every single day. Together, they transformed one of Denmark's greatest natural barriers into one of its strongest connections. Sometimes the greatest engineering achievement isn't defeating nature, it's understanding it well enough to build alongside it, and creating something that endures for generations.